Question number 2, pretty scary looking picture, but it's broken down into nice easy bite-sized chunks so that you can do it no problem at all. So this is just recall. For something to undergo total internal reflection, first of all, you can put this into words, but the refractive index of the incident material, the first material, must be greater than the refractive index of the second material. So N1 is greater than or equal to N. It's actually not greater than or equal to greater than N2, and that's the first thing. So you want to put that into words. A lot of people just got it the wrong way around. So the second one must have a higher refractive index. It's got to be the second medium must have a lower refractive index than the first one. Of course, the other condition is that the incident angle is of course greater than the critical angle. Okay, right. Next up, it gives us the refractive index of glass being 8.0, and it wants the speed. What is refractive index? Well, the refractive index is the ratio of the speed of light in a vacuum to the velocity of light in the medium itself. And so this gives us C, of course, we know is 3 times 10 to the 8. We know A, the value for N of A, I'll give that NA is 1.80. So you can rearrange that to make V the subject. So V is therefore C over NA, which is of course 3 times 10 to the 8 divided by 1.80. If you ever get a value out for the speed of light that's more than 3 times 10 to the 8, you know you've got it wrong. I'll let you find the value for that. Next up here, it says show that the angle is about 30 degrees. So this is the only angle here, over here, that is to be shown. Okay, this is this angle we're trying to find in here. So, well, we know Snell's law, and by the way, I want to see these all actually put in. Calculate the angle yourself, please. N1 sine theta 1 equals N2 sine theta 2. So N1 is air, which is of course a value of 1. Sine theta 1 measured from the normal is sine of 72 is equal to N2, which is N2, which is this glass here, and it says that the refractive index is 1.8. So 1.8 sine theta 2. Sorted. Once we've done that, rearrange, take 1.8 over to there, inverse it to find what the angle is. So we'll say that theta 2 equals inverse sine of 1 times sine 72 all over 1.80. Okay, when you do that, and this is another thing, show that the angle is about 30 degrees. Don't just say equals 30 degrees. Write down the number that you actually find. Okay, when you write down the number you actually find, it will come out to, again, consulting my oracle here, it will come to 31 point something. 31.89. Okay, 31.89. So you show that, and then once you've done that, you want to put equals 30. Okie dokie. Where the marks lay for that, of course, one is for substituting into this equation, one is for the right answer at the end there. Looking on, D, part D, the refractive index of glass C, which is this one down here, is 1.4. So this is 1.80 and this is 1.40. Now, looking at Snell's law, if N1 is greater than N2 for refractive index, which it is, 1.8, N2 is 1.4, total internal rotation can occur. The question is it more than the incident angle? We can see where this is going already. So, calculate the critical angle between glass A and glass C. Well, the critical angle is the angle beyond which, and definition now, the angle beyond which the refracted ray undergoes total internal reflection. Okay, so what we're going to say here is N1 sine theta 1 equals N2 sine theta 2, and this equation is just the same. It keeps coming up and up and up. So N1 is going to be the critical angle. So N1 is going to be 1.8, and sine theta 1 is going to be the critical angle, sine C. And when that is at the critical angle, sine theta 2 will be 90 degrees, which is of course 1. So N2 is 1.4, and this would be sine of 90. Now we all know that sine 90 is 1, so basically that's just 1. We forget about that. So sine C is 1.8 sine C equals 1.4. We can say that sine C is 1.4 divided by 1.8. Therefore C, and I'm going to do this down here, therefore C, critical angle, is going to be inverse sine of 1.4 over 1.8. When you do that, the critical angle comes out to something like 51.058. So you're going to want to give that as 51. Now this is the 4 sig, this is the 3 sig fig. That's to infinite sig fig. So this should really be a 3 sig fig answer. So we're going to want to give that to 51.1. Okay, so that's really what we're looking for there. Next up, E. State and explain what happens to the light ray when it reaches the boundary between glass A and glass C. So let's just have a look. We've just calculated what this angle here is. It's about 30 degrees, but it's not actually 30 degrees, it's 31.89, so nearly 32. So this angle here is, and we might have to be really thinking, this could be a tough one here, let's be thinking this through. 31.9 to 3 sig figs. Okie dokie, that's the angle there. So this angle, if this is just bounced off this thing here, and this line here is parallel to the reflective surface, it means that this angle here is the same as this angle here. I hope you can see that. So this angle here is 30 degrees, and that's the ray, the angle that this ray is coming in, 30 degrees to this normal line. But this angle here is 22 degrees. So with 30 plus 22, oh sorry, not 30, 31.9, 31.9 plus 22 is going to be, it doesn't matter, let's just say it's 32 because that's easier. 32 and 22, it's 54 degrees altogether. This whole angle here is 54 degrees. Now we've just calculated the critical angle to be 51, and the conditions for total internal reflection are N1's bigger than N2, check, and incident angle is greater than the critical angle, check. So state and explain. Okay, so total internal reflection, TIR, occurs, okay, when you're doing it in the exam you write the full word, by the way, because, okay, and we're putting a reason, we're stating what happened and a reason, because, and you can fill in the rest. These conditions are satisfied. Okay, so 1 mark for saying it, 1 mark for an explanation. Once you've done that, of course, this angle here is 52 degrees, so it's going to bounce off at 52 degrees. So that's got this ray here and this ray here want to have the same angle against this normal line. Obviously I don't have a protractor with me, I don't even have a ruler with me, but that's what you want to see. So that's where this second mark comes in there. All right, that is question 2.